Welcome back to Applied Algebra and Trigonometry. Today we're going to be talking about multiplication and division of fractions. Here are some generic fractions that we're going to multiply. When we multiply fractions, we just multiply straight across the numerator and the denominator. This gives us a times t over b times w. And we're done. Division requires a little more work. And the way we deal with division is we multiply by the reciprocal of the divisor. In other words, we keep the first fraction the same. We change division to multiplication, and we flip the last fraction, or write the reciprocal of the original fraction. And then we multiply straight across. So we get AW over BT. A different answer than the original multiplication that we did with those two fractions. Another way that this division could be written is A divided by B divided by T divided by W, because that's what the fraction bar means. It's a division. And we would handle this in the same way. The first fraction remains the same. We change now this division bar to multiplication, and we take the reciprocal of the denominator of this that's called a complex fraction. Pretty good name for it, I think. But the result is the same, AW over BT, whether you write your division this way or this way. I think we should pause for a moment and talk about the vocabulary of division. So here's another example of a division problem with its answer. 3x divided by 3 equals x. All right, we are dividing by 3. We're dividing 3 into 3x is another way to say it. In other words, this is doing the work. So that's the divisor, the worker. Okay, and what is it going into? It's going into the dividend. And if it helps you, mispronounce it dividend, because we're dividing into this number. And then our answer is the quotient. I'm going to quote you the answer. That's the quotient. I don't know. I don't really have a good mnemonic for that. But there you have dividend, divisor, and quotient. And in our example, we have dividend, divisor, and quotient. Time for an example. So it's a multiplication problem. We're going to multiply straight across, but first we will factor completely each numerator and denominator. The fanciest I can get here is to pull out a greatest common factor or 2. And now there is 1, 2 in the numerator here. 2 goes in there 1 time. And 2 goes into 4 twice. I have this going on, x plus 2, x plus 2. And I have an x divided by 1 is, x divided by x is 1, and x divided by x is 1. And now when I multiply straight across, I am multiplying these 1's that I have left. 1 times 1 times 1 gives me 1. And then 2 times 1 times 1 times y minus 1 gives me 2 times y minus 1. It is always helpful to me if you will put a box around your answers. Let's take a look at a division problem in the form of a complex fraction. Well, actually, the first thing I'm going to do is get it out of that complex fraction form. And now that I've done that, I can see clearly that it is 3x over a plus 1 that I will leave as is. I will change my division sign to a multiplication, and I will flip or take the reciprocal of the last fraction, which had been the denominator of our complex fraction. If you are comfortable going from the complex fraction form to this step, that's fine. But now it's time to factor the numerators and the denominators before we perform the multiplication. Let's see, 3x is already factored as much as it can be, so is a plus 1. In our first fraction, the fraction in the numerator, the dividend, there's no factoring to be done. In our second fraction, we can pull out a greatest common factor of a from the numerator and a greatest common factor of x from the denominator before we proceed. When I remember that there are understood grouping symbols in the numerator and in the denominator of a fraction, it becomes clear that I have some things that will cancel here. And therefore my answer is 3a over x plus 2. Is it possible to check these? Sure. I'll just take my answer, my quotient, and multiply it by my divisor. It's not quite that simple though, because before we do this multiplication, we should factor and cancel whatever we can. And once we have done all of that work, then we can see that we return to our dividend. Let's keep going. Let's look at an example 3. Before we can perform the multiplication, we're going to have to factor each numerator and denominator for which it's possible to factor. By remembering my grouping symbols, I can then see that I have some things I can cancel. And x plus a is the same as a plus x, so one of those will cancel. And my final answer is x times 1 times x times 1, or x squared over 1 times a plus x. Here's a challenging example. We will perform the division indicated by this complex fraction by multiplying the dividend by the reciprocal of the divisor. We'll start with the numerator of the dividend. That's a difference between two squares, because x to the 8th, let me write that up there, can be rewritten as x to the 4th squared, and 16 can be rewritten as 4 squared. So we have the difference between two squares, the square root of the first term minus the square root of the second term, times the square root of the first term plus the square root of the second term. I know I usually do it in the reverse order, the positive first, but we'll do it this way today. In the denominator of the dividend, x to the 4th can be thought of as x squared, allowing us to factor that trinomial into plus 3 and, whoops, not plus, careful, minus 1. Okay, so I have taken the factors of negative 3, applied them here and here. I made the 3 positive because it's the larger of the two factors, and my middle term is positive. All right, so we factored the dividend. Let's factor the divisor completely. X to the 6th minus x to the 4th. Looks like there is a greatest common factor hiding in there. X squared minus 1 is left when we factor that out. We'll get to what we do with that in just a moment. Now we have x to the 4th squared and minus 14. What can we do with that? Well, we can factor. X to the 4th would be our first term in each of these factors, and then we need the factors of negative 14 that add to be negative 5. That would be a negative 7 and a positive 2. Well, we need to go further. So, next step. X to the 4th minus 4. That's really just x squared, isn't it? And 4 is 2 squared. So we can rewrite that as x squared plus 2, x squared minus 2, and then we have x to the 4th plus 4. In our denominator, we have x squared plus 3, which will not factor further, but x squared minus 1 will. It will become x plus 1, x minus 1. Anything we can cancel within that fraction? Does not look like it. Let's look at the divisor again. X to the 4th, I can factor x squared minus 1 to x plus 1, x minus 1. And in the denominator, nope, there's nothing to factor there. Next, we will see what we can cancel. Does the factor x squared plus 2 show up in any of the other denominators? No, this is an x to the fourth. How about the x squared minus 2 factor? No. How about x to the fourth plus 4? No, not much canceling here. What about over here? We have x to the fourth. Are there any x's in the denominator by themselves? No. X plus 1, x plus 1, x minus 1, x minus 1. At last we found something we can do. Okay, x plus 1 goes into each of those places once. Divide x minus 1 by x minus 1, you get 1 in each of those places. So our answer is x squared plus 2 times x squared minus 2 times x to the fourth plus 4. It's a long answer. And then that is all multiplied by x to the fourth. So let's put that out in front. X to the fourth divided by x squared plus 3 times x to the fourth minus 7 times x to the fourth plus 2. That's a very complicated problem and a very complicated answer, which means it's quite likely we could have made a mistake. So let's check our work. Make this smaller so I have more room to check. There's my quotient, and I multiply that by the divisor to see if I come up with my original dividend, which is up here. But remember, when I'm multiplying by the divisor, I need to multiply by the divisor as it was originally written, not by its reciprocal, by the original. Our quotient is factored, but the original divisor is not, so let's do that factoring. Thankfully, we have already factored our original divisor here. Now we just need to take all of those factors and write the reciprocal. Now can we cancel some things? Let's see, x to the fourth will cancel. Anything else? How about x to the fourth plus 2? X squared plus 2, x squared minus 2, x to the fourth minus 7. Look at that. Let's start multiplying these terms and see what we get. I'm going to first distribute here, but that's actually going to become the difference between two squares. So it'll be x to the fourth minus 4 times x to the fourth plus 4 times 1 times 1. So that accounts for everything in the numerator. And we have x squared plus 3 times 1 times 1 times x plus 1 times x minus 1, which will give us x squared minus 1. Right, let's take another step. If I multiply the two factors in the numerator, I get this. And in the denominator, I get x to the fourth minus x squared plus 3x squared gives me 2x squared. And 3 times negative 1 is negative 3. Here is the dividend of our original equation. So as you can see, it does check. So since that checks, I'm going to go back up here and I'm going to put a box around my answer because it is correct. Well, I did promise you a challenging problem. The basic operations of multiplication and division of fractions are fairly straightforward. It is the application of those operations to more complex fractions that becomes more difficult. So practice, 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 and I will see you in class.